Well, this section here that we're going to be talking about is relative extrema. And when we talk about extrema, we're basically talking about the minimum and the maximum, the smallest and the largest value in a set. And relative means relative to this particular area. The interval that we're going to be working on here is actually just the open interval from between negative infinity and positive infinity. So we're interested in just probably going to be in this particular part, this particular graph here. So here's our function x squared plus 2x minus 1, and we're going to want to find where this function, I'm going to go ahead and throw in something extra here, where the function's increasing and decreasing, and the point of which it's either a minimum or a maximum, or maybe there's more than one point. There could be a min or a max. As you can see in this graph right here, the minimum is occurring, here's my coordinates up here, and I'm just kind of approximating it, but it's somewhere in this area right here. It's going to be probably x is equal to -1, I'm guessing, and y is going to be equal to, it looks like possibly -2. Alright, as you can see here, reading this graph from left to right, as you can see the little blue dot here, well, the graph is decreasing. The y values are decreasing until we get to the minimum here, and then the graph starts increasing. Okay, so, and we're between negative infinity and positive infinity, so the graph is decreasing from negative infinity, okay, up to -1, and then the graph starts increasing from -1 to positive infinity, and we're talking about values on the x-axis here when we talk about that. Let's see, what else can I throw in? The first thing we're going to do to this function is we're going to take the derivative, and we're going to find what are known as its critical values or critical numbers. We're going to find the critical numbers. Okay, a derivative could possibly exist at these critical numbers, or the derivative may not exist at the critical numbers. Anyway, I'm not going to go into stating any theorems and so forth. The idea here is we want to be able to work some problems out, right? Every once in a while I'll actually state a theorem or two. Well, let's get started on this one. Alright, so let's write it out here. I hate that when that happens. Forget that every time. My canvas is in layers, and that's the reason that happens. But anyway, we don't talk about all that. So we have f of x is equal to x squared plus 2x minus 1. And remember, we're on the interval between negative infinity and positive infinity. Okay, this is the interval we're on. First thing I'm going to do is I'm going to take the derivative of this. So hopefully you guys know how to take the derivative of something as easy as this one here, this polynomial. And then what we're going to do is find the critical numbers. We're going to take the derivative, set it equal to 0, and solve for x. So the solution in this particular one is -1, right? So x is -1. If you plug -1 directly in right here, you get 2 times -1 is -2, and -2 plus 2 is 0, right? So we're looking for the solutions to this equation. And these are, and I'm just going to label this as the critical number Cn. So then what we want to do is we want to draw a number line. Okay, so I want to draw a number line, and on the number line I'm going to label my critical number, and I'm going to put it right here. And then what we're going to want to do is we're going to want to pick a point to the left of -1, and I'm going to pick -2, and then we want to pick a point to the right of -1, and I'm going to always choose 0 if I can. These are known as our test points, and they're going to tell us whether the function is increasing or decreasing, or if the derivative is negative or positive, and then that's going to give us an idea of what this guy is right here, if this is going to be a min or a max is located at this point. Now what we want to do is we want to plug in our test points into the derivative, because the derivative tells the slope of the tangent line at that particular point, right, if it's going to be negative or positive. Well, this section here that we're going to be talking about is relative extrema. And when we talk about extrema, we're basically talking about the minimum and the maximum, the smallest and the largest value in a set. And relative means relative to this particular area. The interval that we're going to be working on here is actually just the open interval from between negative infinity and positive infinity. So we're interested in just probably going to be in this particular part, this particular graph here. So here's our function x squared plus 2x minus 1, and we're going to want to find where this function, I'm going to go ahead and throw in something extra here, where the function's increasing and decreasing, and the point of which it's either a minimum or a maximum, or maybe there's more than one point. There could be a min or a max. As you can see in this graph right here, the minimum is occurring, here's my coordinates up here, and I'm just kind of approximating it, but it's somewhere in this area right here. It's going to be probably x is equal to -1, I'm guessing, and y is going to be equal to, it looks like possibly -2. Alright, as you can see here, reading this graph from left to right, as you can see the little blue dot here, well, the graph is decreasing. The y values are decreasing until we get to the minimum here, and then the graph starts increasing. Okay, so, and we're between negative infinity and positive infinity, so the graph is decreasing from negative infinity, okay, up to -1, and then the graph starts increasing from -1 to positive infinity, and we're talking about values on the x-axis here when we talk about that. Let's see, what else can I throw in? The first thing we're going to do to this function is we're going to take the derivative, and we're going to find what are known as its critical values or critical numbers. We're going to find the critical numbers. Okay, a derivative could possibly exist at these critical numbers, or the derivative may not exist at the critical numbers. Anyway, I'm not going to go into stating any theorems and so forth. The idea here is we want to be able to work some problems out, right? Every once in a while I'll actually state a theorem or two. Well, let's get started on this one. Alright, so let's write it out here. I hate that when that happens. Forget that every time. My canvas is in layers, and that's the reason that happens. But anyway, we don't talk about all that. So we have f of x is equal to x squared plus 2x minus 1. And remember, we're on the interval between negative infinity and positive infinity. Okay, this is the interval we're on. First thing I'm going to do is I'm going to take the derivative of this. So hopefully you guys know how to take the derivative of something as easy as this one here, this polynomial. And then what we're going to do is find the critical numbers. We're going to take the derivative, set it equal to 0, and solve for x. So the solution in this particular one is -1, right? So x is -1. If you plug -1 directly in right here, you get 2 times -1 is -2, and -2 plus 2 is 0, right? So we're looking for the solutions to this equation. And these are, and I'm just going to label this as the critical number Cn. So then what we want to do is we want to draw a number line. Okay, so I want to draw a number line, and on the number line I'm going to label my critical number, and I'm going to put it right here. And then what we're going to want to do is we're going to want to pick a point to the left of -1, and I'm going to pick -2, and then we want to pick a point to the right of -1, and I'm going to always choose 0 if I can. These are known as our test points, and they're going to tell us whether the function is increasing or decreasing, or if the derivative is negative or positive, and then that's going to give us an idea of what this guy is right here, if this is going to be a min or a max is located at this point. Now what we want to do is we want to plug in our test points into the derivative, because the derivative tells the slope of the tangent line at that particular point, right, if it's going to be negative or positive. So we're going to plug in our test points now. So I'm going to take this -2 and plug it into the derivative. Man, drives me crazy. Okay, so f prime of -2 is equal to, so it doesn't matter which side I put this on, -2 times 2 plus 2. Now what we're concerned about here really is not the number, but if this is going to be a negative or a positive. That's all we're really concerned about here. So you have -2 times 2 is a -4, and -4 plus 2 is -2. So this is a negative number. So we're going to say that this is negative, and I'm going to draw a line indicating that the graph is decreasing between -infinity and -1. And then what we want to do is we want to go ahead and plug in our other test point, which I said was 0. So we're going to have 2 times 0, 2 times 0 plus 2, and that's going to be 2, so that's positive. Right, so plus sign, I'm going to put a plus sign here, and that means that the graph is increasing. So we have decreasing and then increasing, so you can see here that this is going to end up being a minimum, a relative min. Okay, this is going to be a minimum at -1. And so now what I'm going to do is I'm going to plug in what is f of -1. We want to get the point on the actual graph here, and that means that we're going to have to remember what the function was. That's going to be x squared, so that's -1 squared plus 2 times -1 and then minus 1, right? And we want to do the math on that, and we should end up getting -2 out. So we're going to end up having a min, and I'm going to write it as a point. It's -1 comma -2. All right, and I'm going to go ahead and add this, that this function is increasing, or we'll say decreasing, and I'm just going to label DEC for decreasing. It's decreasing from -infinity up to -1, and it's increasing from -1 to infinity. And we can see that just by looking at this graph right here, okay, that the function is going to be decreasing from -infinity to -1 and then increasing from -1 to infinity. And of course, if you go back and look at the graph, you can actually see this. Now remember that this is a relative. It's relative to that one little area right there, even though it is, in a sense, it is an absolute. But anyway, okay. Let's move on to another problem. Okay, let's see here. We've got f of x is equal to x squared minus 6x. So let's work it out first and then look at the graph. So the first thing we're going to do is find those critical numbers. That is, we're going to take the derivative, set it equal to 0, right, and solve for x. So it looks like that if we plugged a 3 in right here, 2 times 3 is 6, and 6 minus 6 is 0. So our critical number is going to end up being 3. And so what we're going to do here is we're going to draw us a graph, put 3 here, and then we want to pick some test points, and I'm going to always pick 0 because 0 is the easiest thing to pick, and then we'll pick 4 right here. So then we take our test points and plug them into the derivative and see if we get positive or negative. So I'm going to take 0, plug it in up here. So 2 times 0 is 0, but then we're left with a minus. Alright, I had to break this video up, so I forgot where I left off, but I think we're plugging test points in. Plug 0 in, and you get 2 times 0 is 0, and then you get minus 6, so that's a negative number. So that means that this function is decreasing from negative infinity up to our critical number here, which is 3. And then what we want to do is take this 4 and plug it into the derivative, and 2 times 4 is 8, and 8 minus 6, and that's going to be a positive number, right? So that's all we're concerned about, if it's a negative or a positive when we're doing our test points. So that means that it's going to be increasing from 3 to infinity. So as you can see here, that this guy is going to end up having a relative min right here when x is equal to 3. So what we want to do is actually find that point on the graph, and we're going to do that by taking 3 and plugging it directly into our function up here. So I'm going to plug 3 in, and we get 3 squared minus 6 times 3, and that's going to end up giving us, I think negative 9. Okay, negative 9. So the point, so we're going to get a min, let's label it as a min, a minimum at 3 comma negative 9. Okay, minimum's going to occur there. Let's go ahead and talk about the graphs increasing and decreasing. So it's decreasing, I'm just labeling it as DEC, from negative infinity up to 3, and the graph is increasing from 3 to infinity, as you can see here. Alright, let's look at the graph real quick. Alright, first thing I'm going to say here real quick is how I'm getting this graph. If you're not sure, anybody can do it. Just plug this plug the function directly into the Google search results, and this is actually Google's calculator, or Google's graphing instrument here. Anyway, so let's give some credit for Google. This is really nice. As you can see here, the minimum is occurring right about here, and we said that that was at 3, negative 9, so we can kind of look at our coordinates up here, and I'm going to try to get as close as I can. Well, anyway, as you can see, that's as close as we can get. So the graph is decreasing, right, up into 3, and then it's increasing, right? So that's really nice to look at. And of course, we've got nice little zoom features here. We can zoom out and see what's going on. Okay, let's move on to another one. Oh man, I do that every single time. Okay, let's say that we have f of x, and we're going to need to make that a little darker, aren't we? F of x is equal to 2x cubed plus 3x squared minus 12x. So the first thing we want to do is take the derivative. Got to find those critical numbers. So the derivative is 6x squared plus 6x minus 12. And what I'm going to do is I'm going to factor a 6 out of here. Pull one out. 6x squared plus x minus 2. We're setting this equal to 0. I guess the next thing I'm going to do is probably factor this. And let's see what we got here. Negative 2, so we're going to need about a plus 2 and a minus 1. Okay, I believe that factors right. X plus 2, x minus 1. Alright, so our critical numbers are going to end up being negative 2 and 1, right? What can I plug into here to get 0, and what can I plug into here to get 0 also? So that would be the solutions to this equation, negative 2 and 1, and those will be our critical numbers. So now we want to take our critical numbers and plot them on a graph. So let's do that. I'm going to have to scroll down the screen. So I'm going to attempt to draw a straight line here, straight horizontal line. So we end up putting, I'm going to put -2 here. Just kind of arbitrarily pick a spot, and then I'm going to put 1 here. Now we're going to choose a place to put our critical numbers, and let's say 0. 0 is always a good one. -3, and let's say 2 over here. Okay, so we take our critical numbers and we plug them in, remember, to our derivative. Now here's always a nice thing to do. I'd plug them into the stuff that's factored. So this is our derivative here, and use the one that's factored because it's always nice. So remember, all we're concerned about if it's negative or positive. So I'm taking the derivative and I'm plugging -3 into it. So come up here. Okay, I'm going to use this one here. So plug -3 in. -3 plus 2 is a -1. -3 minus 1 is a negative, and so we have a negative times a negative, so that means that becomes a positive. So we're not concerned what the actual number is, just if it's negative or positive. And now we want to do f of 0, f prime of 0. So plugging 0 in, you get 2, plug 0 in, you get -1, and 2 times -1 is a negative. So we end up with a negative number here. Oh, and there's something I forgot to do. I always like to draw a line that's got a positive slope, right? That's increasing up to our critical number here. And then we're going to draw one going down because we have a negative between -2 and 1. It means it's decreasing. And then, of course, we're going to take 2 and plug it in. So f prime of 2. Okay, so plug 2 in, you get 2 plus 2 is 4, and then 2 minus 1 is 1, and you get a positive times a positive, and so that becomes a positive number. And I'm going to put a little plus sign here indicating that right over our critical number, and then a line going up indicating that the function is increasing. Okay, so it looks like we're going to have a relative max around -2 and a relative min around 1 right here. And so to find those points on the graph, you just plug -2 into the function, plug 1 into our original function to get the actual y values. So I'm going to go ahead and do that. So it looks like we're going to have a maximum, okay, at -2 comma f of -2. And we're going to have a min at 1 comma f of 1. Right, so that's plugging these guys in right here and getting that number out. I guess I'll just go ahead and tell you that this number right here is 20, and this number here is going to be -7. So we know that this guy is increasing from -infinity up to -2. Now I'm going to use this symbol here. This is the union. And from 1 to infinity, and that it's decreasing from -2 to 1. And that's it, decreasing from -2 to 1. Okay? Alright, let's hit another one. I don't know, did we graph this? I can't remember if we did or not, but graph it and check it out for yourself. Alright, we are studying relative extrema. This is the function that we're going to be looking at in this next problem here. And I went ahead and graphed it out, and looking at the graph here at Google Graph. The Google Graph. Anyway, So as you can see here, there's going to be a minimum that's going to occur right here. It looks like at 0, 0, and there's going to be a relative max, also sometimes known as a local max and a local min. Anyway, so we got a local max. It looks like it's occurring at 2, I guess 2, 4, and then 0, 0, right? And you can see that the function is decreasing, and we're talking about x values here, decreasing from negative infinity up to 0, and then the graph is increasing from 0 to 2, and then it looks like the graph is decreasing from 2 out to positive infinity. All right, well, let's get busy with the math. All right, so that function, once again, was, we'll call it f of x. Boy, f is overrated, I guess. I need to try something else. We have 3x squared minus x cubed. And so we're going to take the derivative, because the goal here is to find that critical numbers, and that's going to be a 6x minus 3x squared, and we're going to factor out a 3x. We always try to factor things out here, and that's going to leave us with 2 minus x, setting it equal to 0, and then looking at the solutions to this equation. Well, it looks like our critical numbers are going to be 0 and 2. So the critical numbers is 0 and 2. So the next thing we want to do here is try to, I'm going to attempt to draw a horizontal line. Okay, I'm going to plot my critical numbers. I'm going to put 0 here, and then I'm going to put 2 here. And then the next order of business, we got some test points. Negative 1's a test point, we'll say, and 1 is another test point, and we got to pick another one out here, and we're going to pick 3. And so we're going to take our test points, we're going to plug them into our derivative, and I prefer plugging them into the factored derivative here. And all we want to do is determine if the number is going to be positive or negative. Okay. All right. So let's do that. We got f prime. I'm going to plug negative 1 in, and I'm going to plug it into this. So this is going to be negative 3, plugging negative 1 in over here. That's going to make that a 2 plus 1, and so you're going to end up with a negative times a positive, and so that's going to end up becoming a negative number. I don't care what the number is, just whether it's negative or positive. And then we got another test point we got to try. We're going to do 1 here, plug 1 in, so 3 times 1 is 3, 2 minus 1 is 1, and so we get a positive and a positive, so that's going to be a positive number. And whoops, something I forgot to do, put a minus sign here saying that it's decreasing, and then a positive saying the function is increasing. And then now we want to plug a 3 in. So f prime of 3, right, so 2 minus 3 is going to be a negative 1, and 3 times 3 is 9, so we're going to have a positive times a negative, and that's going to be a negative, right? That's going to be a negative number. So we're going to say negative here, and that means that the graph is decreasing. So decreasing, increasing, decreasing, it looks like we're going to have a minimum around here at x equals 0, and then we're going to have a relative max at x equals 2, as you can see here. Alright, and so okay, so I'm going to say the minimum at 0, comma, so we need to plug 0 into the original function. In other words, this is going to end up being f of 0. But to find out what f of 0 is, Right, we just plug it in, and it's 3 times 0 squared minus 0 cubed is 0. Right, so f of 0 is equal to 0. And then we've got a relative max occurring here at 2, and I'll just label this as max. That would be 2 comma, and I guess in short we would say f of 2, but you need to replace this f of 2 here, even though I'm writing it there, with plugging 2 in, and I believe we get 4 out. So you might want to check that. So we got decreasing from negative infinity to 0, and then increasing from 0 to 2, and then decreasing from 2 to infinity. And I guess I'll just write that right here. So we've got decreasing, just shorthand it there as DC. So we said from negative infinity to 0. Right, so that's an interval, and we'll just union that with 2 to infinity. That's where it's decreasing. All right, and then we'll just shorthand that with increasing, and that's going from 0 to 2. 0 to 2. Alright, well that finishes that problem, and I think I've got a couple more left here that I'm going to work. Okay, so got a new problem here, and we're trying to find the relative min and max. Here's our function up here. It's x plus 1 over x. And so as you can see here, we've got the graph, and of course this graph comes from Google on their search page. If you just type that into the search results, you can get this same graph to come up. Okay, we can see that in this this graph here that the graph is increasing, and it's increasing from negative infinity up to somewhere right in here. Right, so here's our coordinates over here, and we can kind of see. So taking a close look at the y value, it's going to max out at, it looks like probably -1. Okay, the x value is -1 and the y value is -2.00. Okay, and then if we look over here, oh, I should say that it's going to be I guess decreasing, let's see, increasing and then decreasing from -1 to 0, it looks like. And then we got decreasing from 0 up to 1, and then it starts increasing. Okay, so it looks like we've got a maximum here, relative max here, and a relative min right in this area here. Well, let's do the math. Okay, so our function, and as usual I call everything f of x, is x plus 1 over x. And so now what we're going to do is take the derivative of this, set it equal to 0, and find our critical numbers. Now, I think what I'm going to do here is, what's the best thing to do? I don't know. I think I'll just get this all into one solid fraction. So multiplying x over here, so we end up with x squared plus 1 over x. Alright, now we're going to take the derivative of this. So we have f prime of x equals, so take the derivative of the numerator, this is the quotient rule, times the denominator minus the numerator times the derivative of the denominator, and the derivative of x is 1. Okay, and then we put that all over the denominator squared, so we're going to square that. Alright, now what I'm going to do is just kind of clean it up a little bit. So we have 2x squared minus, I'm going to go ahead and distribute this minus through here. So we end up with 2x squared minus x squared, then minus 1. Okay, distributing that negative across, and of course that doesn't affect anything. And that's all over x squared. And of course we can simplify this down. Now what I'm going to actually do here is I'm just going to go ahead and simplify it down and then set it equal to 0. Okay, so 2x squared minus x squared is x squared minus 1 over x squared. So I'm going to take the numerator and first set it equal to 0 and find the solutions to this equation. So it looks like if we were to plug in 1, we'd get 1 minus 1 is 0, so one of our critical numbers is going to be 1. And if we plugged in negative 1, negative 1 squared is 1, and 1 minus 1 is 0, so the other one, critical number, is negative 1. Now, we have one more critical number, and that's going to be what makes the bottom down here 0. In other words, if we were to set this equal to 0, the denominator, well, the solutions to this equation here is just 0. So that's going to be our other critical number. Okay, so we're looking at this graph. This is on Google's search page here, if you just type that into the search results. Anyway, this is our function x squared over x squared minus 9. And so by taking a look at this function here, the graph of the function, we can kind of see a lot of what's going on. However, we're going to do the math and prove this stuff. But by looking at this, it looks like right in this area right here, we've got a maximum, a relative max, and doesn't look like we have any other minimums or maximums. You can see the y value over here. If you watch the dot, okay, it's decreasing and decreasing, 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 and so forth. Alright, well, let's get busy with the math. Alright, so writing this out, we have f of x, of course, is equal to x squared over x squared minus 9. So the first thing I want to do is take the derivative. So I'll write f prime of x is equal to, so we take the derivative of the numerator, and derivative of the numerator is 2x times the denominator minus the numerator times the derivative of the denominator, and derivative of x squared is 2x, and the derivative of 9 is 0. Alright, so we're done with that. And then of course, down here in the denominator, we have to square that. So that becomes x squared minus 9 squared. Alright, so now what we're going to do is we're going to clean this up. So f prime of x is equal to, now I'm going to distribute this 2x across, so we have 2x cubed minus 18x minus 2x cubed, and that's all over x squared minus 9, right, quantity squared. F prime of x is equal to, now as you can see, we have a 2x cubed and a minus 2x cubed, so they're going to cancel out, and we're just going to be left with a negative 18x over x squared minus 9, quantity squared. Okay, finally we took the derivative. Oof. Now what we want to do is set it equal to 0 and find these solutions to this equation. And those solutions are known as the critical numbers, but we're also looking for numbers that make this undefined. like vertical asymptotes. Okay, those are known as critical numbers also. Just to clear that up, there is a critical number theorem, or is it a definition? I don't know, that I hadn't officially stated, but okay, so we take the numerator and we set it equal to 0. And of course, the solutions to this equation, better write CN again down here, right? Okay, so our critical number is 0, right? That's the solution to this equation here. And then what makes the denominator 0, right? This is where our vertical asymptote is taking place. So we set that also equal to 0, and we find the solutions to this. Now don't worry about that piece right there. We're just interested in this guy here, okay? Well, you know what? I better just go ahead and add it. People might get confused. But 3 is a critical number. When you plug 3 squared in, you get 9, and 9 minus 9 is 0, and 0 squared is 0. So 3 is one of them, and negative 3. Right, we plug negative 3 in, we square it, we get 9, 9 minus 9 is 0. Okay, so here's our critical numbers here. Alright, so now we're going to do our number line. And I'm going to plot 0, negative 3, and 3 on our number line. And then of course we got test points like negative 4, negative 1, and let's see here. We're going to put a 1 here, then 4 will be our other test point. So now we want to plug our test points into the derivative. And let's see if I can actually... oh man, I can't get the whole thing on the screen. Let's just do this. I'm going to rewrite the derivative here. We have f of x is equal to x. Oh, no. We're doing the derivative. Sorry. F prime of x is equal to negative 18 x over x squared minus 9 quantity squared. Alright. And let me scroll back up. So if we were to plug negative 4 into the derivative, now remember, all we're concerned about is if it's negative or positive. This way I can put my little sign right here. Plug a negative in the numerator. Okay, first off, a negative in the denominator is squared, so this is going to always be positive down here. Alright, so we plug negative 4 into the numerator up here, and negative number times negative 4 is a positive number. So we know that that's a positive, so I'm going to label that with a plus, and I'm going to say that it's increasing from negative infinity up to negative 3. Now we take a negative 1, plug it in. We get negative 18 times negative 1, so that's a positive. Alright. Now we take 1, plug it in, and negative 18 times 1 is going to be a negative number. So we know that that's negative. So that's going to be decreasing. Plug 4 in, and that's going to end up being a negative number times 4 is a negative. So that's going to be negative, and therefore that's going to be decreasing. So if you go back and look at the graph, you'll see it. Okay, now what we want to do, since this is going to be our only relative max here, is 0, we want to take 0, plug it into the original, and that's going to be our relative max. So we're going to have, say, our relative maximum is going to occur at 0, comma, f of 0. And of course, remember that f of 0 is going to be equal to 0. Okay, plug 0 in to the original. I think think that's up here somewhere. Let's scroll up and look at it. Somewhere way up here. Okay, right, plug 0 in, you get 0 squared is 0, so you get 0 in the numerator, right, and -9, so that ends up being 0. Alright, moving back down again. Alright, so 0, 0. Now we can say that this function is increasing Okay, it's increasing from -infinity up to -3. It's -infinity to -3. It's increasing. And then let's see here. Oh, and see, we have a vertical asymptote right here, so this is extremely important, right? So you can't say it's increasing from -infinity up to 0 because nothing's going on here at -3. So we're going to go ahead and union that with it's increasing from -3 to 0. May have not talked about that in the last time. And it's decreasing from 0 to 3. And then we're going to union that with it's decreasing from 3 to infinity. Of course, right? Decreasing and then decreasing again. Well, that concludes this on relative extrema. I may actually work another part to this, but that's going to be it for